In number 3, it asks us what are the zeros of the function. You could graph this to find the x-intercepts, or you can factor it. Take out a GCF first. GCF is x, so we're left with 11x minus 6. And zeros are where the function itself equals 0, or where f of x equals 0. So we're going to set each of these factors equal to 0, and we'll have x equals 0, or 11x minus 6 equals 0. If you solve each of those for x, you get two solutions. One is x equals 0, and the other is positive 6 divided by 11. In number 34, it asks you to graph the equation. You can do this in your calculator, and it will be multiple choice. On a piece of paper, you're just going to type this into your calculator and get a few values from your calculator to use. It's going to be the regular log function moved down 3 spaces. Normally the log function has an ordered pair at 1, 1, or I'm sorry, at 1, 0. So it has a point right about here, if you can see that red dot. And it goes something like this. It's got a vertical asymptote at x equals 0. So this function, because of the minus 3, is going to move down 3 spaces from where it was. So instead of having a x-intercept at 1, 0, we're going to move that x-intercept down 1, 2, 3 spaces. And so it's going to be something like this. Number 35, find the x-intercepts of this graph. Remember, x-intercepts are zeros, or roots, or solutions. You can solve this by looking at a graph in your calculator looking for the x-intercepts, or you could factor it like we did on number 33. We're looking for two numbers that multiply to give us an 8, but add together to give us a negative 2. Sorry, negative 8 and negative 2. It's going to be negative 4 and positive 2 are the numbers that we need, because negative 4 times positive 2 gives me a negative 8, and negative 4 plus 2 gives me the negative 2 in the middle. So those are my two factors. And to solve this, I'll use some space from number 36. I just need to set each of my factors equal to 0, and then solve. So x equals 4 or x equals negative 2 are my two solutions. In number 36, we're given this picture that's way down here. It says, in circle Q, what is the measure of angle CAB in degrees? So trace that angle in order of the letters that it gives you. So we're looking for the measure of this angle, angle A. This one actually looks like what it is, but the reason it looks like it is because, as you notice, if angle is on the circle like this one is, point A is on the circle, then we're going to take the measure of the arc that's inside of that angle, which as you can see is a semicircle, 180 degrees, and divide it by 2. So angle A equals 1/2 of the arc, 180, which means angle A is 90 degrees. In number 37, it's asking us to find which object's distance is modeled by an exponential function. And as you can see, some of these are exponential and others are either quadratic or linear. So this is a linear equation. If you graph that, it would be linear. The only linear one that we have on here is the runner. Next off, we have a quadratic equation, x squared. And an x squared function is a parabola. It's kind of hard to tell the difference between the train and the bicycle, the way it's graphed here, because you can't see the other half of the parabola. So we'll look at the next one. This one is an exponential equation because it's got an x and the exponent up there. So which of these is the exponential, which of these is the quadratic? Well, you can see right here, the bicycle stops growing quite as quickly, and the train keeps growing very quickly. You can see that its slope is steeper, so it's going to get bigger even faster. That's what exponential functions do. They get really big really, really fast. They start off really small, and then they get really big. So the train is our exponential function. If you were confused by this picture, you could type all of these into your graphing calculator and compare them there, and then see how those compare to the graph that you see down here. So the answer to 37 is the train. For number 38, we've got two functions, and it's asking us to use a table of values to figure out the solutions for the equation f of x equals g of x. F of x is all of this. So I'm going to replace f of x in this equation with all of that. And g of x is this. So I'm going to say negative 3 divided by x plus 4 equals x plus 3. Now I can solve this equation. It's going to take me a few steps, but if you think about what the question is asking a little bit more carefully before we start solving it, you'll see that the table gives us kind of a shortcut for this problem. Because what I can do instead is I can just say, well, if this is a table of my f function and this is a table of my g function, let me use the right colors, f function and g function, where are they equal? Because that's what it wants me to know. They're definitely not equal here. 24 over 7 is not equal to 0. They're not equal here either. They're not equal here either. But they are equal here, and they are equal here. So what's the solution? Is the solution what I just circled, the 4 and the 6? Or is the solution the x values, the 1 and the 3? Remember, in this equation, we would be solving for x. That's what we want to know. This is telling us what the sides equal. If I substitute a 1 in, I'm going to get a 4 on one side, on this side, and I'm also going to get a 4 on this side. If I write the problem the way I'm supposed to. That's supposed to have a plus 3 there. Sorry for that confusion. I think I blocked it out with my circle there. So if I substitute a 1 in for x, I'm going to get a 4 on both sides of this equation, which is why x is a solution. So 1 is a solution. If I substitute a 3 in for x, I'm going to get a 6 on both sides of this equation. So 1 is a solution and 3 is a solution. So that's how you answer that one. In number 39, we're just asked to evaluate the expression. And remember, squaring something means multiplying it times itself. So 3 minus I times 3 minus I. You can make a box for that if you want to, or you can use FOIL, or you can do this one in your calculator. We're going to multiply 3 times 3 and get 9. 3 times negative I is negative 3i. 3 times negative 3i, 3 times negative I is negative 3i again. And then negative I times negative I is positive I squared. Remember, I squared is equal to negative 1. And these are like terms. So I'm going to replace this with a negative 1 and combine these together. So replace with negative 1. And now you can see we have even more like terms. 9 minus 1 is 8. And negative 3i minus 3i is negative 6i. So the answer to number 39 is 8 minus 6i.